In this video, I'm going to review some basic rules for multiplying. We're going to review the box method or the tabular method for multiplying, as well as double distributing. And then we're going to take a look at a pattern that hopefully you'll recognize, which we start to call our special products. Because if we can identify our special products with multiplying, we can use a shortcut and a rule rather than spending time double distributing or expanding out our products. So let's take a look at numbers 1 and 2. I'll do number 1 with the box method and then number 2 with double distributing. So if you have a preference, you can see both. Number 1 says a plus b times a minus b. So if I'm going to use the box method, I have a binomial times a binomial. So I'm going to set up a 2 by 2. And if you remember from algebra 2, probably you set it up with the top and the right. So we have a times a, which gives us a squared. A times b is ab. A times negative b is negative ab. And b times negative b is negative b squared. So on your diagonal is typically where you have your like terms. And you'll see here that they cancel each other out. If you want to write it out first, you can, but you don't have to. And we end up, when these cancel each other out, with a final product of a squared minus b squared. And like I said, I'll do number 2 as a double distribution. So we have 3y times 3y, which gives us 9y squared. 3y times negative 5 is negative 15y. 5 times 3y is a positive 15y. And 5 times negative 5 is a negative 25. So if you had done the box method, you would end up with these same terms. They would just be organized in the box as opposed to in a straight line. Once again, my middle 2 terms are going to cancel out. We end up with 9y squared minus 25 as our final answer. Take a look at the next 2. So these are both written condensed. They don't have 2 binomials, but remember that something squared means it's multiplied by itself. So this is really a plus b times a plus b. So you could write this out, and then it's exactly like the previous ones that we just did. Why don't you take a minute to pause, try it on your own, and then hit play to check your answer. So you should have done this on your own, so I'm just going to run through it really quickly because you should just be checking your answers at this point. We should have a squared, ab, and b squared. This time on the diagonal, I have like terms. I have a 1ab and a 1ab. Remember that we are adding. So our final answer should be a squared plus 2ab plus b squared. And then the same thing with number 4. This could be expanded to be a minus b times a minus b. Hit pause on the video, give this one a try on your own, and then hit play to check your work. Running through this one again quickly since you're just checking your work. We have a minus b, a minus b. So we have a squared minus ab minus ab plus b squared. Remember, a negative times a negative is a positive here. My diagonal are my like terms again. So I end up with a squared minus 2ab plus b squared. So now there is a question where I'm asking you to compare the difference between numbers 1 and 2 compared to numbers 3 and 4. So let's take a look at all of them together. You should have this on your paper as well. So you should be able to follow along. Take a minute, look at it, see if you can come up with the difference between them before I recap what's happening. So if you notice in numbers 1 and 2, my answers, the middle terms dropped out or they canceled each other out. They were additive inverses. In numbers 3 and 4, that did not happen. And the difference is the signs in the question. So in numbers 1 and 2, my binomials that I'm starting with have opposite signs, one positive and one negative. So my middle signs, my middle terms become additive inverses of each other, and they give us technically a +0, and we don't need to show that. In numbers 3 and 4, remember this was really a plus b times a plus b. It's being squared, which means you're multiplying by itself. So that means that my terms are going to be the same. Notice how in this one, they're both positives, and then this one is both negatives. So they are not going to be additive inverses and become opposites to cancel each other out. So that is the difference between 1 and 2 compared to 3 and 4. Numbers 1 and 2 you may recognize. It's kind of the reverse of dots for factoring, difference of two perfect squares. If you took the answer and you were asked to factor, that's what it would factor to be. Numbers 3 and 4 are special products. They are a binomial squared, and we're going to look at the special product rules for a binomial squared as well as a binomial cubed. But for right now, we're looking at a binomial squared. So there are two questions for you to try on your own using this rule. So technically, these are your rules for a binomial squared. You're going to square the first term, square the last term, and in the middle, you're going to do 2 times those two pieces put together. So I'm going to do one with you, and then you're going to try the 2 on your own. So here we go. If I have something like 3x minus 7 squared, I'm going to write down my rule that we essentially just created on the side. A minus b squared is, a squared minus 2ab plus b squared. And if you can memorize that, it's just going to make this a lot easier. So I could sit here and expand and do the box method or double distribute like we did, but I can go right to, this is my a, this is my b. So it's really going to be 3x squared, which is 9x squared, minus 2 times my two terms multiplied together. So I have 3x times 7, which is 21x, times 2 is 42x. And then I have plus the b term squared. So my last piece squared is going to give me 49. So like I said, there are two questions for you to try on your own. Give them a try, and then we will go over those and we'll talk about other special product rules in class as well.